5 sample examples of numerical problems are discussed on this Lecture 1 overview video under Numerical Methods and its Programming channel. 5 sample examples discussed are: the first problem is an arithmetic problem, simple arithmetic problem. The second one is on solving a quadratic equation. Third one is for solving roots of cubic equation. Fourth one is a series summation problem. And the fifth is a dynamics problem that occurs in physics. A general approach to solve such problems are to understand the words, numbers, symbols, and units used in the problem to understand the problem completely. Second step is to understand the computational operations that needs to be performed in solving the problem. The third one is to understand the subject area of the problem to formulate the sequence of steps of simple calculations. The fourth one is to consider the simplest tool to be used to solve the problem. The fifth one is to state the final results as the insight to the problem to answer the questions asked under the problem. The first example on arithmetic problem states the following. A man or woman goes to the farmer's market to buy the following fruits and vegetables. He buys a dozen bananas for 9 cents per banana. He buys 3 pounds apple bag for $2.99 per bag. He buys 10 pounds golden California potato bag for $3.99 per bag. And he buys 6 green peppers at the rate of 78 cents each. He gives $20 to the cashier. The questions are: how much money did he spend on fruits and vegetables, and how much net change he got back from the cashier. Example 1 is a 3rd or 4th grade school word problem taken to understand the important words used to state the problem and the resulting solution. Arithmetic or numerical methods are used to obtain the results of the problem. This same example 1 will be used under lecture 2 to elaborate the details of how to program in a particular computer language. Please note, in real life, the numerical methods used will not be as important as the results obtained or the insight gained. It is important to choose the correct, simplest numerical method to compute the final results in a short calendar time. There are 5 arithmetic or numerical operations that are needed to solve example 1. Addition with a plus symbol, subtraction with a minus or negative hyphen symbol, multiplication with a star symbol or cross, division with a division symbol or slash, exponentiation. These 5 same operations are used in other systems in mathematics, like a complex number system or vector or matrix operations. Example 2 is for solving a quadratic equation. The problem statement is the following. A farmer bought a rectangular farmland with an area of 3,750 square feet. He needs to put a rectangular fence around to cover the whole farmland. He needs to know the length and width of the fence if he pays $5,000 as the building cost of the fence. Assuming that the installation fence cost is at the rate of $20 per foot of built-up fence, determine the length and width of the fence built. Of course, the solution is length is 75 feet and width is 50 feet. and cost of fence is 5,000. To solve this problem, some knowledge of algebra and quadratic equation formula or lecture 4 of finding the roots of equation functions is needed. Of course, the hints for solution, there are two conditions given: 2 times the length plus width equals 250, where 250 feet is obtained as a perimeter by dividing 5,000 by 20, and the area as L times W, which is 3,750. Of course, we can formulate as a quadratic equation and solve this problem. The third example is on finding the roots of a cubic equation. Of course, there are many applications of this finding the roots of a cubic equation, which we'll discuss later as time goes on in other lectures. The cubic equation written here is in a general form: ax cubed plus bx squared plus cx plus d equals 0, where a, b, c, d are numerical constants of the cubic equation. For a numerical example with a equals 1, b equals -7, c equals 14, d equals -8, the solutions, the roots are x1 equals 1, x2 equals 2, x3 equals 4. Of course, we need a knowledge of algebra and lecture 4 to understand how to solve the roots of functions, roots of cubic equation. The fourth example is on a series summation. Here it is stated to compute sine of 40 degrees without the use of the calculator. This was the case when digital machines were not available before 1900s. Of course, we can use the calculator to find the answer as stated here, and we can talk about the series summation formulation by use of a Taylor series under lecture 3. The example is a dynamic problem. A parachute person of mass 75 jumps out of a hot air balloon, stationary hot air balloon. It is assumed that the air resistance is linearly proportional to the instantaneous velocity of the parachute person. Assume the drag coefficient is equal to 12 kg per second. The questions are: what is his velocity at 12 seconds after the start of fall, and also the terminal velocity when his weight is equal to the air resistance. Of course, we can find the solution at 12 seconds as 9 meters per second and terminal velocity as 61. We need to have some knowledge of physics and differential equations to formulate the problem, and we can express the velocity as a function of time, where v of t is g times m divided by t multiplied by parenthesis open 1 minus e raised to minus ct by m, where g is the gravitational constant, which is 9.81 meter per second squared. T is the time in seconds, m is the mass in kg, and c is the drag coefficient in kg per second. Of course, we can solve this by either plotting or by using a program, and we can determine the terminal velocity and the velocity at 12 seconds as discussed above. There are 3 ingredients of any technical problem, and these ingredients are: 1, the numbers used as numerals; 2, the symbols used to state quantities; and 3, physical units of products used, physical units of products. Of course, we can see in example 1 words such as dozen, 10, 3, 6, 44, 2.99, 3.99, 78, per, and cent. And we can see in example number 3 zeros. Now we can also see symbols such as dollar sign symbol, LBS standing for pound, LBS standing for pounds, cent standing for 1/100th of a dollar. And of course, we can see physical units as bag, pounds, etc. The tools that can be used for calculations are 1. A simple calculator or a computer program that one can write and use it on the computer. It is assumed that the user is familiar to use the calculator, and the usage of calculator will not be discussed in this video. For complex problems or dealing with problems having many numbers as input, the use of calculator is not a wise choice to solve the problem. However, this channel will elaborate on the steps to program on a computer, so the viewer can learn the particular programming language as an end to solving numerical problems. Lecture 2 will give additional information on the software tools that are available on a computer and that can be used to program to solve any numerical method. Also, under lecture 2, the above sample problems will be used to showcase the development of the computer program, either in Python or in MATLAB Octave software. The details of writing the code to learn the programming will be provided. Now, let's move on to study many details to understand numbers and symbols in the next few unit videos immediately following this video, as identified under the Lecture 1 Topics video named NMlec01unit02-topics. Of course, here the UnitTube link is given, which you can click to go to that video to see the other unit videos that will be posted on YouTube. Thank you.